In this lesson, we will use inverses to solve a matrix equation, and we'll also learn a new way of solving systems of equations using Cramer's rule. Two lessons ago, we changed a system of equations into an augmented matrix, and today we're going to look at a matrix equation instead of the augmented matrix. And also look at this is the same as that, because if we go 2, 3 times xy, that's 2x plus 3y, 2x plus 3y. Here we have 1 negative 4 times xy, that's 1x minus 4y. So this system is the same as this matrix equation. Here, if we just say that's matrix A, that's matrix X, and matrix B, what we're going to do today is have the inverse of A times A and the inverse of A times B. This is the identity matrix. So that would be I'll say I, X. Identity matrix times X is X. So we know that X is the inverse of A times B. That's what we're going to do for part of today's lesson. Alright, let's write it as a matrix equation. So that's 2, 3, 1, negative 4. And we know we're going to need the inverse of this, so let's go ahead and find the inverse. Oops. I have to switch the order on that. So that's going to be negative 4, 2. And then switch the signs there. Negative 8 minus 3. Now let's go ahead and leave. We won't distribute the negative 1 over 11. Let's go ahead and do this work over here first. Alright, let's multiply both sides by the inverse. And so all we did was multiplied both sides by the inverse. These are inverses, so when they multiply, we get 1, 0, 0, 1, the identity matrix. Let's multiply this, then we'll multiply by negative 1 over 11. So we have row 1 times column 1. Row 1, column 1 is negative 8 plus 63. Then we're going to go row 2, column 1, negative 2 minus 42. And we're going to get 55 and negative 44. So now we multiply or divide by 11, negative 5 and positive 4. And we're done. So that's x, y equals negative 5, 4. And you try that one. Pause the video. So we'll write a matrix equation, and let's find the inverse. One over the determinant, and we switch these and change the signs. That'll be 8 minus 3 . So there's the inverse. Let's multiply both sides of the equation by the inverse. And I didn't mention this or didn't remind you that you cannot put this out here because matrix multiplication is not commutative. We have to go multiply on the same side. We can't multiply from the right and then from the left over here. Alright, so we multiplied by the inverse. All of this is the identity matrix. And now we'll multiply that. And that'll be negative 38 minus 19. Here we get negative 57, 40, negative 72, positive 72. And we simplify that and get negative 20. This is negative 38. This should not be a 19. It's negative 1 times negative 18, and that's going to be positive 18. Here we have 3 times 19 and 4 times 18, so that is correct. And then we have 1 over 5. That will be negative 20, and this will be 15. Negative 4 2/3. And that's xy. Okay, that's how we can solve using an inverse matrix. Now let's use Cramer's rule. Alright, and here's how we solve. The value of x is the determinant, getting rid of the x, divided by the determinant of the coefficients. The y is going to be the determinant, getting rid of y, over the determinant of the coefficients. So let's see what all that means. This is the determinant of the coefficient matrix. So we're going to get negative 8 minus 3 is negative 11. This is the determinant when you replace the x with the solution. So this means replace 2, 1 with 2, negative 21. So we get negative 8 minus negative 63 . Here we're going to replace the y coefficients with the solutions, and we have 2, 1. So that's going to be negative 42 minus 2, negative 44. These numbers are familiar from what we just saw in the previous problem, and now we can just say that x is 55 over negative 11, y is negative 44 over negative 11, and now we get the same answer as before, negative 5 and 4. Okay, you try that one. Pause the video. That'll be 8 minus 3 is 5. Replace the x with 19, negative 18. Replace the x coefficients. And now we have negative 38 plus 18, negative 20. Replace the y coefficients with 19 and negative 18. I'm using the wrong symbol here. This should be a straight line and a straight line. And here we have 72 minus 57 is 15. So x is negative 20 over 5. Y is 15 over 5. So we get negative 4 and 3. And rather than finding an inverse of a 3 by 3 matrix, let's use, or we can use Cramer's rule. So let's do that on a 3 by 3. Alright, so D is going to be the determinant of this. And if we had any zeros, we would want to use a row or a column with zeros in it. Let's go ahead and just use the first row. So we know we need 3, -2, and 8. Remember that we have positive, negative, positive, negative, positive, negative, positive, negative, positive. The signs, so this will be a positive, negative, positive, positive, negative, positive. The minors, and when we take the 3 out, we're left with 3, -9, 420. When we take the -2 out, take out that row, take out that column, 6, -9, 420. Here we're going to take the 8 column and row, 6, 3, 4, 4. 60 minus 36. This will be +2, 120. Minus 36, no. 60 minus a -36, that's +36. Here we have 120 minus a -36, so that's +36. And 24 minus 12. We simplify that, we get 696. Alright, let's replace the x coefficients with 38, -12, 0. Now we get a 0. That's a little easier. We replaced the this column with these numbers, and now we will use, let's use the bottom row, and we'll have 0, 4, and 20. We're using the bottom row of signs, positive, negative, positive. So positive, negative, positive, and then multiply that times the minors. Remember that's addition, not multiplication in there. When we take out the 0 column, 0 row, we get -2, 8, 3, -9. When we take out the 4 row and column, 38, 8, and -12, -9. Take out the 20 row and column, 38, -2, and -12, 3. That's 0, so we don't have to do any work there. And here we will have -4 times -246, and then here we'll have 20 times 90. Multiply multiply and subtract. Here we multiply and subtract to get that, which is 2,784. Let's do the same thing and replace the y coefficients. So we're going to replace these numbers with these numbers. 364. Then we're going to go 38, negative 12, 0. And 8, negative 9, 20. Let's use the bottom row again because there's a 0 in it. So 4, 0, 20, 4, 0, 20. And the bottom row is positive, negative, positive, positive, negative, positive. Take out the 4 and we get 38, 8, negative 12, negative 9. Take out the 0 and we get 3, 8, 6, negative 9. Take out the 20, 3, 38, and 6, negative 12. 4 times that, that's 0, 20 times that. And here's negative 246 again, and negative 264. Here we get negative 6264. Let's do the same thing and replace the z column. Replace the z coefficients with these numbers. Okay. And we could use the bottom row again because there's a 0. You could also use the the third column that has a 0. 4, 4, 0, 4, 4, 0, and we have positive, negative, positive. Okay, take out the first column and row, and we get negative 238, 3, negative 12. Take out the last row, middle column, 338, and 6, negative 12. Take out the 0 row, 0 column, 3, negative 2, and 6, 3. 0 times this, so we don't have to worry about that. And when we have this, we get negative 90. And here we get negative 264. So that's 696. X is, and dx was 2784, and d is 696, so this is 4. Y is dy over d. dy is negative 6264 over 696, and that's negative 9. Z is dz over d. dz is 696, d is 696, so we get 1, 4, negative 9, and 1. So that was a lot of work, but I think it's easier than the finding a inverse matrix. And we'll stop there.